Hello, hi everyone. Welcome to the Student the Brand. So now I'm going to discuss about electricity. Electricity. Okay. So in this, now we are going to discuss about electric current. Okay. So CBSE grade 10 physics. So we'll discuss now. So everything we discuss like definitions, statements, formula, and the problems. Everything will be discussing. We'll discuss. So if you have any doubts, you can ask. We'll work out on it. So welcome to the Student the Brand live class. Okay. So electric current. Today's topic is electric current. Electric current. Simply we can say electricity. Electricity. The rate of flow of charge is equal to Q by T. The rate of flow of charge is called electric current. So I am considering the rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. Right? Yes. Rate of flow of charge. Simply we can say definition of electric current is rate of flow of charge. So I hope it is clear. Rate of flow of charge. I equal to Q by T. Here Q is a charge. Here I am considering Q is a charge. T is the time. I is the current. Q is the charge. T is the time. I is the current. So current I am considering. So this is the charge. Charge. So time. Here SI unit of current is ampere. SI unit of current is ampere. So ampere I am considering. Okay. So SI unit of current is ampere. So we should not write capital letters. We should not write capital letters. Okay. We have to write small letter itself starting. On honoring the scientist. So we are writing the name. We are writing the unit. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. Okay. SI unit of time is second. SI unit of time is second. Right? So electricity. So the rate of flow of charge. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T I am considering. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. Clear? Once again, SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. Now we can say 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So 1 ampere equal to 1 coulomb per 1 second. Okay. So here they will ask about define SI unit of current. Define SI unit of current. That time we have to write the rate of flow, the flow of charge, 1 coulomb of charge flowing through 1 second. 1 coulomb of charge flowing through 1 second, that is nothing but 1 ampere. See, symbol we can write capital letter, but units you have to mention with a small letter itself, starting. Okay, starting you have to use small letter. Clear? So that is about electricity. So you know very well. So CBSE grade 10 physics. CBSE grade 10 physics. So by Siva sir, BTech mechanical, 10 years experience in physics teaching. So this is the number where we can get okay, so you can ask doubts, you can ask any notes, so current running topic notes if you want, you can check once. Okay, so I'll post class notes, I'll post class notes, so I'll share the after the class you can join to the whatsapp group is there. So in that I'll post every time the questions. Okay, so related content also I'll post related to CBSE grade 10 physics, all chapters, and time to time questions also I'll post. So WhatsApp channel is there. You can follow the community post. You can check the community post also. So here also there. See, in WhatsApp channel we can share the particular notes. So Telegram channel also there. So you can check the links given in the description. So in the description also it is there. Channel description it is there. So you can check channel description. So all the links given like Telegram channel, Facebook, Instagram, WhatsApp. Okay, so everything given, you can check once, you'll get the CBSE grade 10 physics related content. Okay, I'll be starting the foundation courses also. Based on that also, we'll be getting the notifications. So please do like, share and subscribe to Student the Brand for more content, for more updates. If you want related CBSE grade 10 physics, if you want more content, you can check the channel. Okay, so you can check the updates also. Time to time I'll be updating the content. Okay, so if you have any doubts also, you can check, you can ask me through this number. So if you have any content related so doubts, if you have, you can ask. Okay, that's enough. Now electricity, if you are taking the rate of flow of charge. So the rate of flow of charge, that is nothing but electric current. So I equal to Q by T. So SI unit of charge is what is the SI unit of charge? Coulomb. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of time is second. So if they asked about a definition, okay, so define SI unit of electric current. Define SI unit of electric current means you can define the rate, the 1 coulomb of charge flowing through 1 second. Simply we can see rate of current, we can say 1 ampere of current is flowing through, 1 ampere of current is defined as 1 coulomb of charge. 1 coulomb of charge flowing through the particular unit, 1 coulomb of charge flowing through unit cross section area per second. Okay, so that is nothing but electric current, SI unit of electric current. Clear? So that's enough about electric current. Now next one, so we are going with the yeah, of course. So next one, see, this is my handwritten notes, you can check. you can check the my handwritten notes. You can check clearly. So everything, all details, each and every point I have written. Okay, so here, so this is the notes. So very beautifully written. You can check here. Okay, so like that notes will be there. I'll update these notes, so you can check all the notes. So I'll update these notes in YouTube. Okay, so now YouTube, not in YouTube. So YouTube we cannot share. So post I'll share, and I'll post in WhatsApp group and even Telegram group also I'll post. So one by one, so according to the class what it is going on. So I'm explain. See, so this is the today class notes completely. So we are working on it. Okay, na? So fine. So SI unit of electric current is there. Clear? Next, we'll discuss about charge. Charge. Charge is a property of the matter. Charge is a property of the matter. Okay, which can influence the presence of other charge. Charge is a property of the matter which can influence the presence of other charge. There are two types of charges are there. One is positive charge, another one is negative charge. Positive charge is proton. Positive charge is proton. I'm considering proton. And a negative charge is electron. Negative charge is electron. Okay, positive charge is proton, negative charge is electron. So charge, there are two types. Okay, charge of an electron is 1.6 into. Okay, Rahul. So I will start class 11. Okay, topics also: motion in a straight line, motion in a plane, units and dimensions. So rotated motion, gravitation. So thermal properties of matter, thermal properties of solids, liquids and gases, thermodynamics. These all topics I will start. So because okay, so I hope you are strong in physics then. Very nice, very good, good job. Okay, so you have to balance remaining subjects also to get good rank, to get good marks. Okay, and come to the point. So charge is a positive. Uh, Positive you can say proton, negative we can say electron. Negative we can say electron. Okay. Next, charge of an electron 1.6 into 10 power minus 19 coulomb. Okay. So we can say charge of an electron. Negative if you are taking, so 1.6 into 10 power minus 19 coulomb. Okay. So in 1 coulomb how many electrons are present? 6.25 into, in 1 coulomb how many electrons are present? 6.25 into 10 power 18 electrons. So these are the electrons. If it is goes, how you will get this calculation? Keep smiling. So in one coulomb, how many electrons are present? So this many electrons are present. You can see 6.25. See, from here we can get it like this. So 1 coulomb equal to 1 by 1.6 into 10 power minus 19. Then it goes up 1 by 1.6 into 10 power 19. So if you do this one, you'll get 0.625. So you can 0.625 something value you'll get 10 power 19. So then you'll get 6.25 into 10 power 18 electrons. Okay, so that is 1 coulomb. Clear? Any doubts? Do you have any doubt? Just check once. Okay, next. So that only we got it here. Next one. So that is about the charge and electric current. Next one. Hi sir, keep going. Hi. So your name? Supplier something. So YouTube channel name is that. Okay. Thank you for liking and supporting, and please do subscribe. And Rohit. Thank you, Rohit. Hey Rohit. Someone. So one of my student name is also, see the students names. There are many, so I hope you may know about me. If you don't know, actually one of my student name is also Rohit only, like that. Okay, done. So next one, conventional current and electric current. We'll see conventional current and electric current. Conventional current, conventional current, conventional current, and electric current. Second one is electric current. Electric. So electric current. So what is the difference? Hi Rahul. So I am from Hyderabad right now. Okay, done. So here I am considering about conventional current. Conventional current is nothing but see. Oh, very nice. So conventional current and electric current. Conventional current is nothing but here before finding electron, proton. Hey, hi from Delhi. Nice, nice to meet you. Okay, so conventional current and electric current. Conventional current is nothing but normally before we are finding no electron, proton, neutron. So before that only already they given the statement. Already they given the statement. So scientists were given the statement that is. So if you are taking, I am considering this a battery. So electrical appliances still will discuss that. I will discuss the electrical appliances. So meanwhile just you can take the circuit, electric circuit. This is the electric circuit. So positive terminal, negative terminal, current is flowing through it. So it is glowing bulb. So because it is closed switch, it is closed switch, bulb is glowing, current is flowing, so I current. So actually the flow of positive charges will be taken as current. Okay, still you are considering that. That is a conventional current. So because of electron movement only current will pass. Because of electron movement only current will pass. So before that, before finding electron, proton, neutron, all the things, they already given the statement. So what is that? So the flow of positive charges will be taken as flow current direction. So after that, if you change the statement, what happens based on that statement? There are many theories. Okay, so many proofs, many experiments. Okay, so many experiments done on it. So that's why we can't change it again. We can't change it for instead of changing everything. So just we can change the statement. I will tell one small point. So it's okay means I'll tell, no problem. So actually, one king want to see the entire kingdom in the form of greenery. So you want to see everywhere green. Okay, everywhere you want to see the green. So everything must be in color of green. So like he ordered to everyone. So he ordered like that. I want to see the entire kingdom in the form of greenery. Okay, so in like a green, in the form of green or in the color of green, like that. So remaining all are working so hard to make entire kingdom to get it done in the form of green color. So one person came and said, one person came and said, so king. So I, instead of coloring and doing and spending entire amount for converting kingdom in the form of greenery, just you can wear green color specs, then it appears everything in the form of green color. Right? Yes. So here also, instead of changing all the theories, so all the experiments, so to, no, again everything on the expansion, like all the theories will be, again it will be wrong. Then so many experiments depends on it. So instead of doing all those things, better we change the statement. Better we can change the statement. That is conventional current and electric current. Conventional current is nothing but the flow of charge. The flow of charge. The flow of charge. The flow of positive charges will be considered as a conventional current. The flow of positive charge. Okay, flow of positive charge is considered as a conventional current. Coming to electric current, so the flow of electrons will flow from negative terminal to positive terminal. Electrons will move from negative terminal to positive terminal. So protons, positive charges will move from positive terminal to negative terminal. Conventional current is nothing but, so the flow of positive charges. The flow of positive charges is considered as a conventional current. The flow of negative charges is considered as a electric current. Okay, electric current. Clear? So that's enough. So that is about conventional current and electric current. Thank you. Next one. Next one we'll talk about electric circuit. Okay. So equipment, shall we discuss appliances? Appliance electric circuit is electric circuit is nothing but a closed and continuous flow of electric current. A closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current. Must be it should be in closed path. Current should pass continuously. Then only we can see electric current. Yes or no? So and schematic diagram. Schematic diagram. Okay. So a logical connection of electrical appliances. Logical connection of electrical appliances. So that is nothing but a schematic diagram. Okay, or geometrical representation. It is a geometrical representation also. Right? Clear? Okay, next one we'll go with the electrical appliances. Symbols of electrical appliances. Those are attending the class, kindly do like, share and subscribe and share this no channel live class to all. So if you like, automatically it will be automatically it will be recommended to others also. They will also join to the class. They will also, if you have any doubts, you can ask me. Okay, so that's enough. Come to the point. Electric current, electricity. So I'm taking, this is the switch. So sorry, this is the cell. Cell. First one is cell. Second one is battery. 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 And third is switch. This is the open switch. This is not closed switch. Open switch. Open switch. Open switch. And fourth one, closer switch. Closer switch. Okay, so this is the cell, battery, open switch and closed switch. Open switch and closed switch. Clear? Next one. We'll go with the resistor, 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 ammeter. This is the resistor. ammeter and voltmeter, resistor, it's okay, fine, no problem, right? So this is resistor, ammeter, voltmeter, resistor, ammeter, voltmeter. Next one galvanometer, it is there. Next one wire joining, wire joining, and next one wire crossing. This is wire joining and this is wire crossing. Wire joining, wire joining, wire crossing, wire crossing. Okay, so this is wire joining and wire crossing. Is it clear? Next one, we'll go with the next one more. So these are the electrical equipments, electrical appliances. We'll go with the electrical potential and potential difference. Electrical potential or potential difference. So potential difference. Potential difference. So first one, coming to the second one, electrical potential. Electrical potential. So what is potential difference? Potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from. So I am considering here this is the conductor. So I am taking this the conductor. Work done to bring. So I am taking the positive charge. So I am considering this is A and this is B. Positive charge is there. So we are doing some work. Okay. So V equal to W by Q. Work done to bring unit positive charge from one point to another point within the conductor. So what is the potential difference? Work done to bring unit positive charge from one point to another point within the conductor is called electrical potential difference. Is called potential difference. Coming to electrical potential. So here SI unit of electrical potential is volt and SI unit of work is joule and SI unit of charge is coulomb. Okay, so here once again you can observe here SI unit of potential difference is volt, SI unit of charge is SI unit of work is joule, SI unit of charge is coulomb. These are very important points, so note down. So electrical potential. See whatever points I am mentioning on the board, all are very important. So you can note down. So it will be like a short notes. It's like a quick revision for particular topic. So now I am explaining about electricity. This topic will also helpful for grade 12 students optics chapter like current electricity it is there in grade 12. Clear, and even for JEE NEET students also can listen this class because so everything will be given. So foundation to until higher level standards. So theory as well as problems also I'll be explaining. So actually 100 problems are available, 100 problems are there. Those problems also will try to do it because problems I'll be explaining through. Previously one video I did while solving problems. I kept the video, not like this, not a face to face live class. So it will be like okay, problems. So problems, individual problems I'll be explaining how we have to consider. So what is the data, what is the formula, how to solve it, and so everything I'll explain. Okay, including problems also I'll explain. Clear? Now we can go with that. This is the potential difference. A potential difference is nothing but volt work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Okay, so those who are there in the live class, please do like, share and subscribe to Student the Brand. So you can share this channel and you can like the video. Remaining students also, they can join, so they can get to know live class is going on. So here is a Siva sir is teaching. Okay, so I made videos related to physics. So there are number of videos are available. You can check the channel, go to the playlist, so you can get abundant knowledge. Okay, so here, so potential difference is nothing but work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor, we are doing some work to bring the unit positive charge from one point to another point. So that is called potential difference. Whereas electrical potential, so to the required field. So here infinity I am considering. Suppose infinity I am considering positive charge is there. So this is the required field. Within the conductor, we can also say. So we can some charge. So from one point to another point, okay. We are bringing this positive charge from one point to another point, okay. From infinity to the required field. Here one point to another point, but here from infinity to the required field. From infinity to the required field. From infinity to the required field. Infinity to the required field. Infinity to the required field. So then we can say that is nothing but electrical potential. Same formula will use V equal to W by Q. Same formula we are using. So same formula we are considering. So formula will not change. Formula does not change for electrical potential and potential difference. So only definition first. In the definition itself, some difference will be there. Nothing else. Remaining everything will be same. Okay. So formula will be same. SI unit is same. Clear? Now, so we'll go with the next one. Ohm's law. Shall I explain Ohm's law? Anybody is there? No one. Okay. And here SI unit already said, no? 1 volt equal to 1 joule per 1 coulomb. So we'll take 5 minutes break because 40 minutes class. 5 minutes I'll take. 5 minutes. 5 minutes break we can consider. Then join to the class. Okay. So those are watching after the live class, you can skip this 5 minutes and you can watch once again. So no problem at all. Now those are attending to the class, just wait 5 minutes. I'll join once again. Clear? Okay, so welcome to the live class. So now I am considering the Ohm's law. I'll explain Ohm's law. Okay, so Ohm's law. I'm going with the Ohm's law. So Ohm's law is nothing but at a constant temperature, the potential difference across a metallic wire is directly proportional to current flowing through it. So at a constant temperature, the potential difference across a metallic conductor is directly proportional to current flowing through it. Okay, so I am considering here. So here metallic conductor. Here is ammeter, ammeter, ammeter. One, two, three, four. 1.5 volts. So like 4 cells, ammeter, here voltmeter. Okay. So here you can observe current is passing, current is passing through it, current is passing through it. So the potential difference, at a constant temperature, the potential difference across a metallic wire is directly proportional to current flowing through it. V is directly proportional to V equal to IR. So Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So V is directly proportional to I, V equal to IR, R equal to V by I, R equal to V by I. Okay. So here we have to connect one by one. Like that. So procedure. So what is the process? So process is, so material, what are the materials? Here this is the resistor. So I am considering here is X and here is Y. So first one is 4 cells, 1.5 volts each. Second one, nichrome wire of length 0.5, nichrome wire 0.5 meter length. Third one, ammeter, voltmeter connecting wire switch. So still we can write. So what are those? Ammeter, voltmeter, switch, connecting wires. Okay, so these are the materials required for doing Ohm's law process. First connect one cell, First connect one cell and note down the readings of ammeter and voltmeter. Ammeter and voltmeter. And next one, connect two cells and note down the ammeter reading and voltmeter reading. And connect 3 and 4 cells and repeat the same process. So taking the taking the values of ammeter and voltmeter, you can mention in the tabular form. So tabular form is I'm giving. So tabular form here. Serial number of cells. So ammeter reading, voltmeter reading, V by I, that is nothing but R. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Here, serial number. Serial number you have to take. Number of cells, serial number of cells. Here, ammeter reading and voltmeter reading. So, ammeter reading is here, current, and voltmeter reading is the potential difference. And we have to find out constant, that is nothing but V by R. V by I, that is V by I is nothing but R. So, we know formula, Ohm's law, V equal to IR. So R equal to V by I. So from that we can take. Okay. So we have to consider like that. Understood? So I hope it is clear to you all. Next one, if you draw the graph for this values, see in the board exam you can write as it is like this. So tabular form you can write. Okay. So process everything we can write. If they ask about Ohm's law, generally here this they will ask for 2 marks. So this diagram alone they will ask for 2 marks, and statement, Ohm's law statement, they will ask for 1 mark. And materials, so here nichrome wire is an alloy. It is a combination of nickel, chromium, and manganese and iron metals. Nichrome wire it is an alloy. It is a combination of metals, nichrome, chromium, manganese and iron metals. Okay, so 0.5 meter length, here to here 0.5 meter length, and switch and 4 cells 1.5 volts each. So these are very important about the particular materials they will ask. And next one, so we'll go with the diagram. If you draw the graph, V on y-axis, I on x-axis, you draw the graph, it becomes straight line. That is nothing but linear, starting from origin. Because so initially when you are connecting first cell, so the ammeter is reading it will be 0, voltmeter reading it will be 0. So that's why we can consider we are taking from origin, that is 0. Okay, so from 0 I am considering. So this is about Ohm's law. Clear? So do you have any doubts? If you draw the graph for Ohm's law, so it will be straight line. So starting from linear, so it's a linear. The graph is linear. VI graph for Ohm's law is linear. Ohmic conductors and non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Ohmic conductors means a substance. Simply we can say substances which obey Ohm's law. Those are called ohmic conductors. Good students obeys teacher words, elders words, and they'll follow, they'll prepare, they'll do their work. Okay, so remaining that choice is yours. Okay, so next one I will go with that, like Ohm's law. So non-ohmic conductor which does not follow Ohm's law. Okay, so it depends if temperature changes, resistance changes. So here resistance is there, resistance changes. So we'll see now. And next one I will go with that condition for Ohm's law. What are the conditions? And here condition for Ohm's law is temperature must be constant. So if temperature constant, only Ohm's law will be followed. And one more thing, physical conditions. Here what are the material we are considering? So nichrome wire we are considering, and materials, it depends on material changes. So again resistance will changes. So that is about today class. So if you have any doubts, we will see. And you can check one CBSE Grade-10 physics. So you'll get training from Pro. So CBSE Grade 10 Physics by Siva sir, BTech Mechanical, 10 years experience in physics teaching. So if you want these notes, actually I'll provide the WhatsApp channel and Telegram channel. This whatever I'm today class notes I'll update to you. Just you can check once if you want. Okay, so this is about electricity notes. Those who want classes of CBSE Grade 10 Physics, so you have to pay. So course fees 500 rupees. These 4 chapters will be explained. At the same time, notes will be provided. Okay, so this is about Siva sir. Signing off. Thank you.